Yo, what's going on? I hope that these videos have been helpful for you guys and girls. And here we go, continuing on so I could wrap up the written response questions 51 through 85 on the August 2015 chemistry Regents. It looks like we're up to questions 69 through 72. And here we go. So here it says, in a laboratory investigation, ammonium chloride was dissolved in water. Laboratory procedures and corresponding observations made by a student during the investigation are shown in the data table below. Okay, title of the table says dissolving ammonium chloride solid in H2O liquid. And procedure 1 says measure the temperature of 10 milliliters, which is 10 grams of H2O liquid in a test tube. So one thing to remember that they brought up right there is that the density of plain water at room temperature is approximately 1 gram per milliliter. And that's why if you have 10 milliliters of pure water at room temperature, that's also 10 grams. So the density of plain water liquid at room temperature is approximately 1 gram for every milliliter, or cubic centimeter. Same thing. 1 milliliter is equal to a cubic centimeter. Okay. Anyway, observation. The temperature of the liquid water was 25.8 degrees Celsius. Okay, next. Procedure 2, add 5 grams of the solute ammonium chloride solid to the H2O liquid. Observation number 2, the ammonium chloride solid settles to the bottom of the test tube. Step 3, stir the contents of the test tube for 4 minutes. Observation 3, a small amount of ammonium chloride solid remained at the bottom of the test tube. Procedure number 4, measure the temperature of the ammonium chloride aqueous solution, and the student recorded the observation that the temperature of the solution went down to 11.2 degrees Celsius. Okay, so question 69. Identify 2 types of bonds in the solute. So they want us, class is over. Identify 2 types of bonds in the solute. Okay, so recapping on the word solute. Solute is whatever substance you are trying to add to a solvent to create a mixture. So solute is what gets dissolved. So if you're making hot chocolate, the hot chocolate powder mix, that's the solute. If you're making soup, you put table salt, sodium chloride in the water, that's the solute. So whatever is getting dissolved is the solute. So what the solute in this case is NH4Cl solid, which is ammonium chloride solid. They want us to identify 2 types of chemical bonds in the solute. Okay, so this is where you would want to look for this. Ammonium is a polyatomic ion on reference table E. There's ammonium. And if you look, ammonium is NH4 positive. So you have nitrogen, which is a nonmetal, with 5 valence electrons. If I went to the periodic table, I just don't feel like doing that right now. Nitrogen has 5 valence electrons, so you get a covalent bond with a hydrogen, bringing its valence electron here, and here, and here. That's NH3, which is ammonia. Ammonium has an extra hydrogen, and because this extra hydrogen is using those 2 electrons that nitrogen already had, the nitrogen almost feels like it's missing an extra electron. So that means that it's positive. So that's where you get NH4 positive. So look at my drawing so far. Ammonium is a nonmetal, nitrogen, bonded to another nonmetal, hydrogen. Therefore, those are covalent bonds. But if you look at the formula for the substance, it's NHCl. And chlorine turns into a negative chloride ion. So here's a negative chloride ion. And technically, a negative chloride ion would have 8 valence electrons. But anyway, the bottom line here is that you have nitrogen bonded to hydrogen, so you have a bunch of covalent bonds. But you also have ammonium, which is a polyatomic positive ion, attracted to chloride, which is a negative chlorine ion, which means that you have ionic bonding also. So you have both. So you can remember that most of the time that you see and in the case of the chemistry regions, all the time, if you notice a compound is made up of a polyatomic ion, that compound has both covalent and ionic bonds. So that's the answer for that question. State two types of bonds present in the solute: ionic and covalent bonds. And you would write that answer in your answer booklet. I don't feel like opening it right now. Ionic and covalent bonds. That's the answer. Okay. Next question, 70. State evidence from the investigation that indicates that the ammonium chloride NH4Cl aqueous solution is saturated. Okay. So let's think about a few things that you might see at home when you're making a mixture. So let's say you have a container with a certain amount of water and you want to dissolve some solute in there. Okay, so when you add some solid solute into the water and it all dissolves, meaning you made a homogeneous mixture, that means that you have an unsaturated solution. So if the solute dissolves, that's unsaturated, meaning that the solution, more stuff can dissolve. If you have another solution with some solute dissolved in a solvent, and you try to add more solute, and you notice that it won't all dissolve, and you see a buildup of solid undissolved solute sitting at the bottom of the container, which, by the way, you probably know this, that is called precipitate. Oops. No, I don't want the highlighter. That's precipitate. And if you notice that for a certain amount of a solvent, like water, at a certain temperature, that the solute will not dissolve, that means that the solution is saturated at that temperature for that amount of water that you're trying to dissolve stuff in. So evidence that you have a saturated mixture is that not all of the solid dissolves and you get some solid precipitate building up. So that is the answer for number 70. Evidence, and let me get my pen. There is evidence, and it's right. Keep clicking on the wrong marker. This. The ammonium chloride solid settled to the bottom of the test tube. So evidence is that NH4Cl solid settled to the bottom of the test tube. Now, that's not the only way that you could state that. You could have said not all of the solute dissolved. You could say that there was precipitate at the bottom of the test tube. You could also say there was a heterogeneous mixture because not all of the NH4Cl dissolved. However you'd like to say it, that's how you know this was a saturated solution or a saturated mixture, is that not any more of the solute could dissolve. And you've seen that at home in the kitchen. Okay, another thing. So we've all probably used ice packs, instant ice packs at this point. Well, this is one of the substances, I believe, that can be used or used to be used in instant ice packs. Because if you look at the information from this reading, you'll see that the temperature, let me delete everything else. You'll notice that the temperature of the water before the ammonium chloride was added was 25.8 degrees. But after adding ammonium chloride, the temperature dropped to 11.2 degrees Celsius. That means that by dissolving ammonium chloride, the water lost heat. Now, I know that you're probably thinking, well, losing heat is exothermic. The thing is that the energy was being used in order to dissolve the ammonium chloride, meaning that this process overall, it absorbed energy. So that means that this is endothermic, that absorbed heat. So the evidence is that the temperature of the solution decreased. So it would feel cold if you touched it. The temperature of the solution decreased. So yeah, that's how an ice pack works. You basically have a pouch of water closed inside a bigger pouch, which has a salt, like ammonium chloride, in it. And when you squeeze the small pouch, the water dissolves a salt similar to ammonium chloride, and that reaction is endothermic, and it feels cold. That's how you get an instant ice pack. Oops. Okay. One more question for this part. 72 says, state the observation that would be made if procedure 3 is repeated with the original temperature of the liquid water at 98 degrees Celsius. Okay. So this is where we're going to have to use a reference table about solubility. So let me go back here. Okay. Time to delete all this stuff. All right. So we're going to use reference table, I believe, H, solubility rules. Let me check. Oh, not solubility. Oh, it is solubility. Not solubility rules, though. Okay. So it's reference table. Is everything. There we go. Oh, table G. Solubility curves at standard pressure. So this is different from solubility rules, which was table F. This is solubility curve, meaning how much of a substance will dissolve in a certain amount of water at a certain temperature. So since this problem is about ammonium chloride, NH4Cl, we will go look that up. So NH4Cl in water at 98 degrees, and they said 10 milliliters of water. Let's check the temperature here. So let's go back to that reference table. So there we go. So if you look carefully at this table, let me zoom out a little so we could see it a little bit better. Okay. So if you're looking at this table, we see that the y-axis says solubility, meaning how many grams of solute can dissolve in 100 grams of water at a certain temperature. So if we look at ammonium chloride, NH4Cl, we could see that at 98 degrees Celsius, you would be able to dissolve quite a bit more, right? About how many grams? Let's see, 70, I don't know, 74, 75, around there, maybe more. Grams of ammonium chloride in 100 grams of water, as opposed to, I believe in the question, well, they didn't say that they had 100 grams of water. But regardless, it looks like the water that the ammonium chloride was dissolved in was at 25.8 degrees Celsius. So that's a bit colder than 98 degrees. And if we look at the graph, it shows that ammonium chloride dissolves better at a higher temperature. So then procedure 3, instead of this student in the lab seeing some of the ammonium chloride precipitate at the bottom of the test tube, at 98 degrees Celsius, the hot water would be able to dissolve ammonium chloride better, meaning you would not see precipitate at the bottom of the test tube. You've seen this at home. If you've ever tried to make a drink using very cold water, you'll notice solids don't dissolve very well in cold water. They dissolve better in hot water. So let's see, we can write an observation that would be made if procedure 3 was repeated, but the water was hotter. So let's tell people. All of the, or more of the ammonium chloride, NH4Cl, would dissolve rather than settle to the bottom of the test tube. So basically, it would no longer be a saturated solution. And you could say this another way. You could say no precipitate would form, no solid precipitate would form. Anything along those lines where you would notice that at a higher temperature, more ammonium chloride would dissolve. And again, that's most solids dissolve better at a higher temperature. You've seen this in the kitchen at home. Okay, and I think that will be enough for this video.